Oscillating, everyone, let's. Okay, worksheet from the packet. Did we get through number one? Yes. Yeah, through number one. All right, so let's start number two. So number two, we have cosine of x to the fifth divided by cosecant of x. Define the derivative. What's involved here? Push a rule. Okay, let's try that. Okay, f prime g minus f g prime all over g squared. Right, cosine's derivative is negative sine, cosecant is negative cosecant cotangent. Cosine is negative sine, cosecant is negative cosecant cotangent. So f prime cosine of x to the fifth becomes negative sine of x to the fifth times 5x to the fourth. G function here, f stays the same, and then g prime cosecant of u becomes negative cosecant u, cotangent u times u prime. Ex's derivative is just e.
Didn't you also do product rule?
Yep, that's right. You could also bring that cosecant up as sine and go through product rule. It looks a lot different, but either would be acceptable. Yeah. Yeah, I have it as product rule on my key, but I decided to go through quotient rule here. All right. Any questions with two? All right, number three. We're on page 17 in the packet, and then we'll come back and do that. Do the additional worksheet. Okay, pretty straightforward here. We just apply the rule for cosecant. There's no, and there's a little bit of chain rule, but there's no product or quotient rule or implicit here. On the key, I have finding the second derivative, but we can just stop at first derivative. That's fine. Okay, number 4.
I'll read it the negative. And where did you do double negative stuff?
Oh, so the cosecant derivative is negative cosecant cotangent times u prime. So this negative is the coefficient, and then cosecant will produce its own negative derivative, and then another negative from the u prime. Okay, number 4, what do you see here? Implicit and product, okay. How many dy dx's do we expect to show up? 2, okay. Good. Try that. Okay, let's see if we can put the dy dx terms together on the same side. Notice all the terms are negative, so I can distribute a -1 through both the numerator and denominator and and make everything positive. That's another variation. Okay, number 5. Y equals 2 tangent cubed of x. Evaluate y prime of pi over 4. So we want to find the slope at a point, but before we do that, what would be a helpful thing for us? Yeah, let's get that 3 to be written in a more useful or more helpful position. Here we can clearly see the need for chain rule, right? If we don't, we may, it'll be. Okay. Okay, outside's derivative. We go through power rule there. Keep the inside same. And then tangent becomes secant squared. Replace every x now with pi over 4 to get from our derivative down to our slope. Okay, so tangent of pi over 4, that's easy, that's just 1, right? Secant is related to cosine, so we know cosine of pi over 4 is what? Root 2 over 2, so if I flip that, I get my secant. So this reduced to be root 2 squared is 2, 2 times 6 is 12. Okay, number 6, find the equation of tangent line. Okay, first things first, what should we do before we do our derivative? Let's rewrite it, yep. That squared is only going to see secant, and what's inside secant is not going to impact that 2 there. So there's outside's derivative. Inside, secant becomes secant tangent u tangent u times u prime. Okay. Everything that we need is in front of us here. We can use the x value to plug into the function to get the y, plug in the pi over 6 to get the slope, and then we do point slope 1. Right, 2 times pi over 6 is 2 pi over 6, which is pi over 3. If you're not familiar or as familiar with secant, it's okay. We can just think in terms of cosine. What's cosine of pi over 3? 1/2, right? So if I flip 1/2, that's the rule for secant. With 1/2, I get 2. Then 2 times 4 is 8. So there's my order pair. Oops, sorry, secant of secant of pi over 3. We know again is 2. Tangent of pi over 3. Think about the order pair. Pi over 3 is 1/2 root 3 over 2. So tangent is y over x. That's root 3 over 1, which is just going to be root 3. Order pair and our slope, point slope form.
You just look at an abbreviated constant.
Yeah, possible, yeah. Slope is just some number, right? Can have a square root, sure. Okay. If you guys can turn to page 6 again, you can write down your 6 rules. And before you guys do it though, let's just review them real quick. We know that we like to line up our sine, tangent, secant on one side, cosine, cotangent, cosecant on the other side. All the C functions produce negative derivatives. Tangent and secant, tangent and cotangent have a similar form. Secant and cosecant have similar form. Sine, cosine involve each other. Tangent and secant derivative involve each other. Cotangent and cosecant derivative involve each other. Okay, so let's take a second try at this, see how we do. If we didn't get everything right, hopefully we can make some progress today. Okay, so once you're done, check with the top of the new worksheet that you just picked up today. They have the rules up top and you should be able to confirm how you did. And hopefully each day that we do it, it'll just feel easier. So this it says quiz review here, but I pulled this from the previous years from the non-calculus worksheet that I did with them. So this doesn't have the particle motion. It doesn't have the trig evaluation, but it's still good practice. We're still going to see product, quotient, chain rule, implicit. So let's go ahead and try number 1. And I just want to see how well do we do setting everything up, identifying the rules involved here. So I'll try that and I'll go over each problem, but I want to just see how are we able to get started? Are we able to identify the appropriate rule? 7x minus 2 becomes 7. Maybe even.
What do you say, right, in terms of?
So number one, product rule.
Yeah, that's good. For sure. Yeah. This one's fine. And then that should. 25 is the section. That's your back, yeah, Stephen, you, should. Number two, hopefully it's easily identifiable, the need for quotient rule there. The only cleanup I'm gonna ask is, if it's possible, combine your negatives and your coefficients in front of the respective terms. But no need to worry about GCF or doing any merging. No, this is just cosecant is not standard term. This is inside cosecant. Now it was cosecant x times 4x cubed. It's just short. Okay, so take a look at number 3.
first things first, right? Let's get that exponent to be in a better place for our problem.
Number two, why it's like, when you, it's a G squared at the bottom, why do you only do coaching the square, not square root of purposes?
So that's a shorthand way of saying this. So cotangent squared of 5x minus 1 is a shorthand way of saying cotangent of 5x minus 1. So, yeah, they mean the same thing, but this is fine, that's fine. The reason why people write it this way is so they can do it without writing the brackets. So. Okay, but number three, we definitely want to see those brackets so we can clearly identify the need for chain rule, right? So let me see you guys set up number three. So big bracket. Five goes up. Or goes inside, but then it's those are just. Yeah, or you can just keep it like that, it's fine. So it'll be good and small, that's fine.
You said that,
No, not something like that.
said that five goes up here.
The five goes outside, it goes thinking like this. Right. Then the 4 bracket to the 5th power is your outside function, and inside function is a cosine. So stick it through. Let's see what it looks like. Yeah, let me, I'll go ahead and put it up right now. Okay, so the 5 is going to be outside the cosecant. Now it's much clearer to see, right? Okay, there's an outside derivative I gotta take care of. There's the inside derivative I gotta take care of. Then do power rule for the outside, cosecant rule for the inside, and string them all together. Yeah, the 20, the negative, the 12x squared minus 2, I typically like to push them out in front. But I mean, if you leave that 12x squared after, that's fine. It's just, we don't want to get this confused with what's inside the trig function. So typically we fold those in front so it doesn't get misinterpreted as something that's inside the trig, which it is not. Okay, number 4. Back page. Pretty good. Okay, what do you guys see here? Implicit, is there product rule? No, no product rule, right? So we're gonna expect 2 dy dx to show up. And then the rest is just either trig rule or power rule. Secant becomes secant y tangent y, and then we attach dy dx after the derivative is done. These we're asking for y derivative. 2x becomes 2. Y becomes dy dx, but I like having that 1 in front. So when you take that GCF dy dx out, you remember that there's still a 1 left over. So if you don't have a 1 there, I see some students just forget about that second term there. That's a nice placeholder. Without that 1, it's easier to just completely leave that second term out. Okay. Move the terms with dy dx to the left side, which can factor dy dx out, and divide each over. Okay, number 5, what do you see? Implicit. So this one does have product rule that x times sine y means it. Okay. Product rule, implicit, there's 2 dy dx's that show up. We should factor those out and isolate that variable. Okay, number 6 should feel a bit like number 3. You can set that one up. Okay, so number 6, understand that that fourth root is not to the fourth power, it's to the 1/4 power. So you got the outside portion, you got the inside portion, you got to take turns with each derivative, and each derivative will have their own space. So 1/4 parentheses to the -3/4, cosine of u becomes negative sine of u times u prime. And the only thing I'm going to ask you is resolve negative exponents. So this negative exponent is going to have to be put into the denominator. They can share the same space as before, and everything else will go with you. And so after break, we'll have Monday to review. Tuesday, I'll give you guys another day to review on your own. I do need to start a next set of topics on Tuesday, and then put it on Wednesday after break. Okay, all right, come get your phones. All right, yeah, I can do power four. Yeah, I can bring it up as sine and go power four. It looks different, but it's perfectly fine.
Yeah.
No, you don't have to. I'll set you.
That's so costly. No, you see like line, I don't know why they're doing this. It was like 13 million. One car went back. Oh, wait, right. Yeah, yeah, one car went through the carpool lane. Yeah, all the way behind.
So you mean fans are breaking?
Yeah, just relax.
Yeah.
I'm not going over.
Jake, can I do the unit fire to like up during like this?
That's not.
I'm yeah. I don't know. What's the name? Crazy.
Wait, what's the quiz on this? Like 10 hardest mountains ever used?
What's the effort to use it this moment? Oh.
Not worry about that.
You know, I'm not dead, but
How do you study for that?
walking around. I didn't take unseen. So why did they? What's it gonna say? Saying.
Just relaxing.
They cost me a line.
There's no, I'm saying recently. Hopefully the Bills bounce back, you know. So,
Are they playing,
yeah.
they're not playing on Thursday.
No, they're not. They have for like a while now. Yeah. Like through the last 4 years they played. But I think they're funny jets.
So you know who the what the Thursday games are?
I think 49ers Seahawks is one of them. They're all like NFC matchups.
Like, and then
That's why it's like
The Cowboys and Lions, they always play them.
oh yeah,
there was a wreck.
He's always Packers lines and Washington these Cowboys.
Lions are.
Oh yeah, they're pretty good.
Bam.
I had no idea their record was that.
Yeah.
We played in Detroit last year. We played in Detroit last year.
Oh, okay.
That was like during a great stretch. I played back-to-back games there. He was like, I took one for home game when snowstorm was
Oh,
on.
yeah.
But I think they're off, like our internal off, there's like a lot more energy, so hopefully that'll help.
Okay, yeah.
Wayne Lyle,
We'll need it.
Yeah,
Maybe something.
yeah, yeah, we do. We see one window from around.
I know.
Yeah.
Yeah, after the Jets game at home, we had to go on the road against the Eagles. And then I survived.